Hi guys, so let us start the next question in the series, which is search a 2D matrix 2. Okay, so we need to write an efficient algorithm that searches for value in an m cross n matrix. This matrix has the following properties: integers in each row are sorted in ascending from left to right. Integers in each column are sorted in ascending from top to bottom. So we need to write an efficient algorithm that searches a value, right? So for example, rows are sorted, columns are sorted as well, rows are sorted as well, and we need to find out the target value, which is in this case 5. So I think this is a nice question in terms. Nice question in terms of what? Because some simpler approach would be to so let us say there are total of n rows and m columns. The simple approach would be n log m. To for each in each row we apply a binary search. But if you notice that also another approach could be m log n. For each column apply a binary search. But in each particular, so if you are doing this approach, then you are not using the fact that the columns are sorted. Sorry, rows are sorted. Sorry, columns are sorted. And if this is the approach, then you're not using the fact that the columns are sorted. So these solutions are correct, optimal, but not the most optimal solutions. Why? Because in each of the cases, you are not using the at least one fact that either something is sorted, right? So the optimal approach over here is to solve this question in n plus m time. So how is that possible? So now that we will look now. So first of all, let us say, so let us find out the number of rows, not matrix. Let us say this is m. Oh, not m. Let us say this is mat, which is right. So this is the number of rows. So if n is empty, so is it possible to have a value? No. So return false, right? Else you will have this. So we now know the number of rows, and we also now know the number of columns. So let us say, so what we will do is we will start searching from the corner. Why? Because the top right corner is that particular corner. So what we will do, if the value which we are searching for is greater than this 15, then what I know is all the values on this row are less than 15. All the values in just a second. All the values which are present in this column. Oh God. Yeah, all the values which are present in this column are greater than 15, and all the values which are present in this row are less than 15. So let us say our target element is less than 15, right? So if our target element is less than 15, what does this mean? That the target element won't exist outside this space, right? We are eliminating one entire column. Why? Because target element is less than 15. Now second case is, if the target element is greater than 15, then the target element will always be in this particular subrectangle. Why? Because all the elements in the first row are less than 15. So if we are searching, so let us say that the target element is 5, right? Pretty decent example, by because 5 is located over here. So now 5 is less than 15. So what happened is we reduced our matrix to this particular submatrix, right? Why? Because, oh, sorry, 5 is less than 15. So yeah. So we reduced our submatrix to this submatrix. Why? Because 5 is less than 15. Now what we will do is we will check with 11, which is the next top right corner. So is 5 less than 11? Yeah. So what we did, we restricted our matrix to this size. Then again we checked with 7. So is 5 less than 7? Yeah. So what happened is, we restricted ourselves to this particular subrectangle. Now we will check with 4. So is 5 greater than 4? Yes. Then we are restricted to this particular submatrix, right? So now we will check if 5 is equal to 5. So we found the element. That means what? How many computations we made? So we moved like this, right? So in worst case, what could happen? in worst case it could happen that we can move from here till here, right? So if we want to search for 18, then the time complexity would take would be order of n plus m, right? We will first search all the rows and then search all the columns, right? So that's why in the worst case we would be using order of n plus m time complexity. So now we are at, so we know number of rows, we know the number of columns. So what will happen is while target, so while mat of m minus 1 and m minus 1 is not equal to, so is it guaranteed that a target exists in the row? Oh, obviously no. Yeah. So what will happen is, so if this is not equal to target, then what will happen? We need to check if if the value, so let us say int v value is equal to this particular value, right? Which is very easy to implement. So if this value is less than target, that means what will happen? If the value is less than target, the value is 5, then we need to bring our column one down, right? Now, else we need to bring our row one down. Now, at the same time, we also need to make sure that when we are shrinking, so n should be greater than equal to 0 and m should be greater than equal to 0 and this case. So in the worst case, it could also happen that the element is not present, and so if n is greater than equal to 0 and m is greater than equal to 0, that means we have found our value, so we will return 1, else we will return a 0. So I think that was all from my side on this question. Let us see. So there is a runtime error. Let me check. Addition of unsigned overflow. If value is less than target. Okay. We need to check the first row, last column. My output is coming out to be false. First row, last column. So now we are searching for the target. Okay, so we have the value. So since the value is less than target, we reduce RAM. Sorry. Why? Because N and M are not the indices; they are the places. So they should be greater than equal to 1. So let us print the values. First of all, we are getting 15. All the time we are getting 15. So is 15 is 15 less than target? So target is, oh shit, so this should be the case. If target is less, then so yeah, I mistook the value as the target. So now we can also check. So first of all, it will be at 15, then it will be at 11, then 11, then 7, then 4. Okay, okay, okay. So if I have reduced my n, okay, 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 okay. So let me check. Let me do it right there. And so basically, we will be moving. So R should be less than equal to n, less than n, and you make not this. You make it this, and you make it this, and you make it this. You close this, and now I think we are good to go. Why? Because first of all, we are searching at row 0, then we will shrink to row 1, then row 2, and also over here it should be is less than n, right? Yeah. Now I can submit it and check if it is correct or wrong. Yeah, so we are good to go. This is the approach. So I think, yeah, that's all from my side.